So, hello everyone. In this particular video, I'm going to tell you the second method of printing the permutations of a string or a vector, that is using the swapping method. Now, in the first method that we did to solve this particular problem, what was the thing that we were doing? We were actually just simply checking for a particular element that whether it is being already taken into consideration or not using what? Using a map that is commonly called as hashing, and we were making simply this is equal to 1, that is checked, or this is 1, or we used to mark it unchecked if it is not present. We were simply creating a frequency array kind of. So this was that. But in this particular method, we are simply not going to use that particular frequency map because basically it's an array. And as I have told you that space complexity is quite determined by your variables, especially your arrays and your those data structures, which can store a series of elements that is contiguous. So we will simply be using like swapping method, which doesn't take into account any extra space, so that doesn't contribute to your space complexity. So this is your swapping method. And now how do you do this? So again, I will be taking the very same example that I took last time. That is, you have got a vector of size 3. That is, you have got three elements in it, 1, 2, and 3. So now, if I go to this particular index, that is your 1, 2, and 3. Now you do what? As I've told you that we will be employing the uh, thing of your called as something called as your swapping. So how do you do this? So basically you do this like swapping, you will be swapping at every particular index with all the numbers given in will all the numbers given in the given this particular vector. Like you will be doing what? Like you will be swapping one with one as well, with two as well, with three as well. Now see how do you go for it. You swap this one with one. So you have got this particular possibility, that is you have swapped one with one. So you have got to one, and your pointer comes to this particular two. This is your pointer, and this is like this. This has become this. Then you swap one with two. That's what I said. That in swapping, you will do what? You will swap each element with all the elements given in the vector. So now when you swap one with two, then it will become 2 comma 1 comma 3. Pointer always comes to the next index, and then there is a possibility that you swap like 1 with 3. So this comes 3, 2, and 1. Pointer as usual comes to this index. Now, as you know that left side recursion executes first. So if this executes, then you know that your pointer is at what? Your pointer is at this index, that is first index. So you have got two options that you can swap. You will swap like you will swap what? You will swap. You can't swap. You know that you can't swap back two with one. You know that because there is no meaning. You have already taken into possibility. It will again become the same thing. So you know that you don't have to swap two with one. So you know that there are two possibilities. You will swap this two with two, and in that you will be getting here something called as 1, 2, and 3. A pointer will always move to your next index. Then you have got another possibility in which you will be swapping 2 with 3. So you have got here as 1, 3, and 2. Pointer moves to this particular index. This is the condition. Now, you know that your left part of recursion executes first. So, moving on, we will be having here, you have got here as 1, 2, and 3. This is what it is. So, now you will be doing here what? You will simply be taking here, you have got here as reaching 1, 2, and 3. So, you have got the possibility, you have reached here. So, have you got any other element? Like, have you got any other element after 3? It it is not. There is no element placed after 3. So here is just one. again you can't swap 3 with 2, that is of no meaning. So you have got just one possibility, and that is your 1, 2, and 3. That is you swap 3 with 3. As I've told you initially that you have to swap each element with all the elements given inside the vector. And in correspondence to that, your index always increases. So now your index becomes equal to, that is the size of the given vector. Is that so? So you will do what? You will simply push that this particular permutation inside a vector, which will be your vector because it will be containing all the permutations. Simple. So you will do this. Now in process, you will do what? You will actually return. So you will reach this particular stage, 1, 2, and 3. Then this 1, 2, and 3 will reach this particular stage. As simple as that. So this particular stage will reach. And at this particular stage, this was the index. So now this index is what? Now you have to swap, like you have to swap these two elements in order to reach here. 1, 3, and 2. Is that so? When on backtracking, remember this, when on backtracking, you reach 1, 2, and 3, and your pointer is obviously at this particular index. So you will be doing what? You will simply be swapping these two numbers, that is 3 and 2, in order to reach here. And this 1, 3, and 2, you don't have got any option after 2, so you just have to do what? You have to just swap 2 with 2. That is, you will be getting here 1, 3, and 2. And then at last, you will simply again return this, and this process will continue. So, as you know here, that the time complexity will still remain the same. That is, for number of elements, you have got the possibility. Just understand this, that here you have got for number of elements. Understand this here. For number of elements, for each element, you have got the total number of possibilities somewhere is equal to 2 to the power n. That is taking into account if there are n elements. Remember this. If there are n elements, then it is somewhere close to n, and you are pushing, so this will be simply n. So if I write here your time complexity, so your time complexity becomes big O of n 2 to the power n. As simple as that. Your space complexity will be equal to the number of permutations itself. It won't take into account any other thing. Your space complexity will simply be equal to n factorial. There won't be any extra space. Your auxiliary space, the number of recursions, you know that they are somewhere equal to the number of recursion calls that are being made here is equal to the number of elements present. So, of your auxiliary space will be big O of n. So, moving on to the code, we have got the code. So the code here, there are two functions. The very first function does what? It actually finds the permutation and it simply pushes it inside the final vector that you have to return. Now, how does it that? Initially, you are at the index. Like here, the loop will run from index because there is no point in if you have reached that particular index. So understand this. Like, as I told you, there is no point if you have reached here. As simple as that. Remember this. There is no point if you have reached here, then you have to swap this back again because this will result into the very same thing that you have done. So there is no possibility. So what we will be taking into account, we will be running a loop from that particular index to the side, and we will doing what? We will be swapping those two particular numbers, that is this. And similarly, every time we will be incrementing the index. There will be a time coming, there will be a time when your index will become equal to the size. So then you have to do what? You have to simply push back and you have to return. You have to backtrack. While you backtrack, you have to again swap it. Now, how? As I told you, that suppose you have reached 1, 2, and 3. Then you backtrack and then you reach at this particular place because this recursion is already done. So this will be pushed. And then you know that what will be the possibility. So it will be simply like this, that this will be the index. Then you swap these three two, and then you come here. So this is the method of swapping. And then I have created a function which will just simply take that particular value, because here the vector answer vector is doing what? The answer vector has simply got all its elements inserted. Then you have to take this vector. So you are doing what? I have declared here a vector of vector. I have declared here a vector which will be storing the permutation temporarily. I have called the function. Then I have returned the vector which has got the all the permutations. Created a vector, calculated its size, created a nested vector you can call, and here called it, and then simply printed it. So hopefully now we are getting the answer, which will be same as the one that we did. So what is the problem here? Just let me check. So hopefully we'll getting that was not anything that was basically that was not a serious error. That was basically it wasn't a technical error. So you can just simply check it. You have got here your permutation. Now it is running again because I never cleared the terminal window. So just see, this is the you have got in total your six permutations, and these are quite similar to the one that you did using the hash technique. So this is all for this particular video, and hopefully you understood it. You can just see here. This is all for this particular video, and hopefully you understood it. Thanks for watching. Do like, share, and subscribe. Thanks everyone for watching. Do like, share, and subscribe.